Alrighty, example number 2. Erica is baking several loaves of bread to sell in his bakery. He used 12 cups of water and 6 cups of whole wheat flour. How much water was used per cup of flour? I want to see if you can try this one on your own. Pause the video, teachers, and let them see. Can you fill in this part of the proportion, and then put your 1 over here where it goes? Pause the video, try it on your own. Hopefully, in reading, you guys were able to see that there were 12 cups of water. My water number is in my numerator, so I need to plug the 12 in there. And then it was 6 cups of whole wheat flour. Flour number is on the bottom. That's like flour you cook with, not the flour you smell. How much water was used per cup of flour? How many cups are we trying to figure out? Remember, it's just 1 cup. If it was more than one, it would say cups. 1 cup of flour because it's a unit rate. So I'm trying to find this 1 here in my denominator. So now I want you to try the next part. What number can I divide my numerator and my denominator by to simplify my fraction? What can I divide my numerator and denominator by to go from 6 to 1? And then I do the same thing from 12. Tell me, what number do you think it is? Hopefully you said 6. 6 divided by 6 is going to give me that unit rate of 1 cup of flour. What I do to my denominator, I have to do to my numerator to keep it proportional, to keep them equivalent fractions. What's 12 divided by 6? 2. And again, you can use your calculator. There's no shame in the calculator game. You do get that for this unit. So this means that for every 12 cups of water, I have 6 cups of flour. So if I have 2 cups of water, that means I need 1 cup of flour. So we will need 2 cups of water per cup of flour. Oh, there you go. I was in the way, you couldn't see it. Go ahead, teachers, pause the video. Let students finish filling out their proportion and writing that statement. To show you guys and to prove to you guys that these are equivalent fractions, we can check to make sure we got the right answer. Checking is always important. That fraction bar, what operation is the fraction bar? That fraction bar means to divide. This fraction bar also means to divide. So if I divide my numerator by my denominator, I should get the same number, and that's how I know I'm right. So let's try that. If I do 12 divided by 6, I get 2. Over here, if I do 2 divided by 1, I get 2. Are those numbers the same? Yes, that's how I know they're equivalent fractions. That's how I know my answer is correct. I divide my numerator by my denominator. Let's try again. 35 songs in 5 minutes. The fraction bar means what? Divide. So if I do 35 divided by 5, I get 7. And then on this side, if I do 7 divided by 1, I also get 7. Do my 7s match up? Yeah, that's how I get the right answer. Is there something else that you guys notice about after we divide? this number I get when I divide here is my answer up top here. Huh. This answer I get here is my answer that I got up top there. On the front page, if I did 45 divided by 5, what do you think my answer is going to be? 9. My answer here is going to be the same answer I get over here. They both equal 9. So another way that you can calculate your unit rate is just to divide that fraction that you already have. That's going to give you your answer over there. Because sometimes it's dividing by 5, it doesn't work too well. It's kind of hard sometimes to see when we see fractions inside of a fraction or when we see decimals. But if you just divide this number, you're going to get the same right answer. Let's try our next problem like that. So we're going to go down to this example. Don't worry about filling in this unit price up top. We're just going to go straight into the example. So this one, Josie spent $36 on 4 tickets at the fair. How much did one ticket cost? We could divide them both by 4, or we know our fraction bar means what? Our fraction bar means division. So let's just go straight to our calculator and see what we get. Oops. 36 divided by 4 gives me 9. So that means that my answer should be $9. And let's check if we go this way too. It's the same math. Dividing by 4 this way or dividing by 4 this way, I'm still going to get that 9. Dividing by 4 here or here, I'm still going to get 9. And that'd be $9 for how many tickets? For 1 ticket, because my unit rate is always going to be 1 in my denominator. So down here it says the cost per unit or per ticket is $9. Teachers, go ahead, pause that video and let students finish writing for that problem. Alrighty, let's come back up to the top and fill in what this unit price means. Before we were doing a unit rate where the denominator is 1. A unit price is the same thing. I still want my denominator to be 1, but now a unit price is the cost per item. The cost per item. So in that example, it was the cost per ticket. Over here it was the cost per mango or the cost per gallon. It's the cost per item. So what you want to do is you want to write the price as a unit rate. Divide the numerator and the denominator of the rate by the denominator. The biggest part here is just knowing that a unit price is the cost per item, per one thing. Denominator is always 1. Always, always, always 1 for our denominator. And again, it doesn't matter if you do the divide going horizontally or the divide going vertically, you will get the same answer choice. You'll get the same answer. Let's go on to one more example, and then you're going to have some time to practice on your own. 4 potted plants cost $88. What is the price per plant? Go ahead, try to fill in the numbers here on your own. This problem's a little tricky. One of your numbers is in word form. Pause the video real quick, teacher, so that students can have a chance to try to fill in this information on their own. Alrighty, let's see how you did. 4 potted plants. 4 is my number here. Is that going to go on top or bottom? Bottom. It's a plant number, so my 4 is going to go on the bottom. And the cost is $88. 88's on top. Money is always going to go on top. Money is a dependent variable, like you learn about in science class. Dependent variables always go on top. The money number will always go on top. Let's write that down. Your money is always on top because it's a dependent variable. And then we're trying to figure out the price per plant. For how many plants? One plant. We're trying to find the unit rate. So I could do 88 divided by 4 vertically to get my answer. Or to go from 4 to 1, I would divide by 4. Either way you do it, you're going to get the exact same answer. Let's go ahead, teachers, and pause the video and have students use their calculators to solve this problem. Have them figure out how much it's going to cost for one plant. Hopefully in your calculators you did 88 divided by 4 and you got $22. $22 for one plant. So the price per plotted plant, that's hard to say, that should say potted, not plotted. Per potted plant is $22. $22 for one plant. That's kind of expensive. That better be a nice plant. Alrighty. I'm going to have you try this practice problem on your own. Set up your fractions first. Set up your fractions first. Where are things going to go? Remember, money's always going to be on top. So first, teachers, pause the video and have students just practice filling in their numbers for their proportion. Alrighty, hopefully you got $12 and 3 miles on one side because those two numbers go together. That's how much Joshua actually walked and his cousin gave him money for. We're trying to solve how much his cousin paid for 1 mile. We don't know what that number is, but what could we do to find out? Divide. So again, we can think about it vertically or horizontally. We're still dividing. 12 divided by 3 would give me what? Would give me $4. And if I went about it horizontally, I would do 3 divided by 3, and I would do 12 divided by 3. Either way, I'm going to get $4. So his cousin paid $4 per mile. I guess it's his cousin, it's not him. His cousin paid $4 per mile. This strategy of just dividing your rate only works for unit rates. This strategy of dividing vertically does not work when you're trying to do butterfly multiply, when you're trying to see if two things are equivalent or finding missing values. For those things, you need to butterfly multiply. It is only unit rate that you can just divide the numerator and the denominator. You now have 4 practice problems to do. Go ahead and let's give you guys between 15 and 20 minutes to get those set up. Or wait, yeah, 15 minutes or so to get those set up and solved. If you have questions, please see your teacher.